Well, hey guys, I think I was going to make a video here. That way, if you want to make some corrections on your uh, geometry test number one, part A, I didn't do the construction part. If you have questions on the construction part, come see me and we can just work one-on-one on it. It's just easier to do that way. But for the first, 15 problems, I'll go over this. And if you make corrections and tell me why you missed it, then I'll go ahead and give you a half of point for each one. All right, guys. So let's go ahead and take care of this real quick. All right. All right. Let's take a look at the first problem here. Okay. So question one says that if the sum of the measures of two angles is 180 degrees, then the two angles are complementary. Well, there's two things. We got complementary and 180. Well, no, complementary angles do not add up to 180. They add up to 90. They're talking about supplementary angles here, so that's false. So that should be a, that's just making sure you're paying attention. Okay. The next one, if the sum of the measures is 180, if the sum of the measures of three angles is 180, then they are supplementary. No, that's false. Now, why is that false? Isn't 180 equal to supplementary? If you just see 180 and supplementary, you might say, hey, that's true. But the problem is right here. I was being tricky here. The measure of three angles. No, supplementary angles always are two angles. Okay, supplementary is always two angles, not three angles, not five angles, not 180 angles, two angles. So what makes this false is the three there. Just making sure you had a good definition, a good understanding of the definition of supplementary. Okay. If two angles are adjacent and supplementary, then the angles form a linear pair. So what are we talking about? So if you have a line, if you have a line like this, and you have another line like this, and this is angle 1 and angle 2, well, angle 1 and angle 2 are adjacent, okay? Because they share this common ray right here. Adjacent angles always share a common ray. This blue ray right here, they share a common side. So angle 1 and angle 2 share common side, that blue common side right there. Also, we see that angle 1 and angle 2 add up to 180 degrees. So they are supplementary. Two angles that add up to 180 degrees are supplementary. They're also adjacent. So correct, that is true. They are a linear pair. That's by definition. Two adjacent angles that are supplementary are considered to be a linear pair. All right, question 4. If angle A and angle B are both supplementary to angle C, then angle A is congruent to angle B. Okay, so what's going on here? So let's say we have angle A and angle B. Okay, so let's say we have angle C over here. Okay, this is angle C. All right, and let's say I got this angle over here. This is angle A. And let's say I have this angle over here. This is angle B. Okay, now think about what this is saying. It's saying angle A and angle B are both supplementary to C. So the measure of angle A plus the measure of angle C equals 180 degrees. Also, the measure of angle B plus the measure of angle C equals 180 degrees, right? So if they're both equal to 180 degrees, let me give myself a little bit more room. You can kind of just like common sense is going to tell you that they're going to be equal to each other. But if you just make a little, so if they're both equal to 180 degrees, then we can set, by substitution, we could set this part of the equation equal to this part of the equation. Okay, see that? Because they're both equal to 180 degrees, by substitution, then we can replace anything with 180 degrees with its equal, equivalent expression. So what we can say now is we could say that the measure of angle A plus the measure of angle B, sorry, erase that, I said that wrong. The measure of angle A plus the measure of angle C is equal to 180, But that's equal to the measure of angle B plus the measure of angle C, because they're both equal to 180 degrees. This side is 180 degrees. This side is 180 degrees. Now notice we can use our rules of algebra here, and we can simply just subtract off the measure of angle C on both sides. So when you do that, you get the measure of angle A is equal to the measure of angle B, because measure of angle C canceled out. And if two angles have the same measure, then they are congruent. So this would be true. Okay? Hopefully that made sense. All right, vertical angles are always congruent. Well, you know it. We proved that in class, so that's an easy one. Vertical angles are always congruent. Doesn't matter if lines are parallel or not. If it's two angles are vertical, they are congruent, period. What is the relationship between angle 1 and angle 3? So if you look at angle 1 is this guy right here, this red angle. See that? And then angle 3 is this, we'll say this purple angle right here. Well, those angles point to each other, right? So those angles are vertical to each other. They're not complementary, because complementary means they add up to 90. I don't know if they add up to 90. They're not adjacent because they don't share just one common side, and they're not supplementary because it doesn't look like they add up to 180 degrees. Okay, so they are vertical angles. Very important that we can find vertical angles in a drawing anytime. Okay, also just kind of a little 2 and 4, those are also vertical angles, right? Didn't ask about that, but it's always good to be able to identify those vertical angles. And remember, from problem 5, vertical angles are always equal. We're going to need to know that all year long in geometry, okay? All right, angles. Which two angles form a linear pair? Okay, so let's see here, 1 and 3. Do 1 and 3 form a linear pair? No, because they are vertical angles. Do 2 and 4 form a vertical pair? No, because 2 and 4 are vertical angles. Do 2 and 3? Well, yes, 2 and 3 form a linear pair because they are adjacent. They share this common ray right here, and they form a straight line. So it's going to be 2 and 3. And obviously D, 1 in itself, no, that's weird. Okay. All right, number 8. What is the measure of angle X? Well, the way I would do this is, what is the measure of angle X in this problem right here? Well, the first thing I need to do is I need to just go ahead and see that they are a linear pair. See that? They're a linear pair, so I can write an equation. X plus 60 equals 180 degrees. And then I can just subtract off 60 from both sides. 60 cancels 60, so I get X equals, let's see here, 0 to, I'm getting 120 degrees right there. X equals 120 degrees, because 120 plus 60 equals 180. Okay, what is the relationship between angles 4 and angle 6? Angle 4 and angle 6. Those are alternate interior angles, because remember, alternate interior angles make the Z. They're angles that form the Z. They're on the interior of the two parallel lines, and they alternate on each side of the transversal. So they're on the interior of the parallel lines, and they alternate on each side of the transversal. So they are alternate interior angles. And if those two lines are parallel, they're equal. Okay, an overpass intersects. What must the value of X be to ensure that the two lanes are parallel? Okay, so first of all, we need to look at this relationship. So if you look at 4X and you look at 2X plus 12, what is the relationship between those two angles? Well, they are same side interior angles. They're on the same side of the transversal. This is our transversal. And here, and these are our two lines, line L and P, we'll say. So they are on the same side of the transversal T, but they're on the inside of the two lines that should be parallel. So what do we know about same side interior angles? Same side interior angles must be not congruent. They must be supplementary. So if we take 4X plus 2X plus 12, they have to equal 180 degrees. Same side interior angles are always supplementary. And you can just kind of just see by the picture, they're not congruent because one is an obtuse angle and one is an acute angle. So we don't want to set them equal to each other because same side interiors are not always congruent, but they're always supplementary when the lines are parallel. All right, so let's combine some like terms here. So 4x plus 2x is 6x plus 12 gives me 180 degrees. Then we'll just say 6x and we'll subtract 12 from both sides. We'll subtract 12 from both sides. So this gives me 6x equals 180 minus 12. Oh, let's see here. That becomes a 7. That's a 10. That's an 8. 7 minus 6 is 7 minus 1 is 6. So I'm getting 168. 6x equals 168. So I'll divide both sides by 6. So I get 168 divided by 6. So 6 goes into 16. Let's see here. It goes in 2 times. So that's 12, right? 16 minus, that's 4. 6 goes into 48 8 times. So 6 times 8 is 48. Remainder of 0. So x must equal, I don't think you want to put x equals, you just want to put 48 in there. Okay, that's what I got. All right, hopefully my math was correct on that. What's the value that makes the 2 points parallel? Well, those two are what we call alternate interior angles. So we know when lines are parallel, alternate interior angles must be congruent, or their measures must be equal. So I know that x plus 25 must equal 2x. Now this just is a simple solve for x. Well, what I'm going to do is I'm going to, since they have variables on both sides, I'm going to attack the weaker variable, and I'm just going to subtract an x from both sides to make my life easy. So on this side, we get 25. This side, 2x minus x is just x. So x equals 25. Okie dokie. Moving on here, guys. All right. Let's see here. Okay, so this got a lot of you some got. Okay, so suppose those two are 3 and 7. So we're talking about 3 and 7. Now, to get the full points here, you have to mention that they are corresponding angles. Okay, so on the test, you may have missed a point. This, I believe, when I was grading this, was out of 3 points. So you may have missed a point, even if you got this angle problem right, all the math, but if you need to mention that they're corresponding angles. Because remember, when lines are parallel, corresponding angles are equal. So you have to mention something about corresponding angles needing to be equal, okay? All right, so if lines are parallel, then the corresponding angles have to be equal. Now it tells us x equals 15, right? All right, so when we do the math, we get, I think we get, so if we take 4x plus 12 and we plug in 15 for x, we get 4 times, 15 plus 12. And then we also get 80 minus 15. Well, 4 times 15 minus 12, 4 times 15 minus 12. Let's put in a calculator to make sure all my math looks good. That equals 48. And if we take 80, oh, by the way, my bad. It's 4 times 15 plus 12, my bad. So 4 times 15 plus 12. Make sure we get that right. That's 72, my bad. It's 72 because it's plus. I put minus in there. Now, this is 80 minus 15. So 80 minus 15 gives me 65. So we get 72 is not equal to 65. Therefore, corresponding angles are not equal. Therefore, those lines are not parallel. So you need to explain something like that in that problem, okay? Corresponding angles need to be equal for this to be true. They are not equal because one is 72 and one is 65 when you put in an x. So therefore, you are not parallel. Okay, number 13. Write the equation of the line that passes through with the given information. Okay, so, perpendicular. Perpendicular. So what's the rule about perpendicular slopes? It's an opposite flip. So all we're going to do is we're going to look at the slope. All we're going to do is we're going to look at the slope right here, this 3/2. We're going to flip it and change the sign. So our perpendicular slope is going to equal -3/2. Okay? And then we just want to throw away the rest of that equation. All we want to do is just steal this slope, make it perpendicular, and then get rid of that equation. Now we're going to use this piece of information to figure out what our b is. So remember our equation, y equals mx plus b. So we're temporarily going to plug a -1 in for our y value, because this is remember, this is an x value and this is a y value, equals, and then we're going to put our perpendicular slope in, which is -3/2, and then we're going to multiply that by our given x value, which is 3. Yep. And then we're going to say plus b. See that? Okay, so now what are we going to do? Let's just make sure everything looks good. We got -3/2. Our x value is 3. Our y value is -1. All right, so now we have -1 equals, well, -3 times 3, that's -9/2 plus b, right? Okay. All right, so now what we're going to do is we're going to add -9, or add 9/2 to both sides. Add 9/2 to both sides. Okay. And then what we're going to do after that is 9/2 cancels 9/2, so we get b equals. All right, so now if we get common denominators, this is -2/2, right? So what is -2/2 plus 9/2? That's going to be 7/2. Is what I got, 7/2. And I believe we wanted our answer right equation in line. So our equation is going to be y equals -3/2x plus 7/2. And I believe I wanted you to write that as a fraction. Okay, hopefully my math looks right. That's such a weird answer here. I'm making sure everything looks good. I put a -1 in. I flipped it. Oh, wait, Mr. Roden, I apologize. Scratch this. Okay, sorry about that. Let me start over on this. I don't know how to edit this screencastify out, so I apologize. Mr. Roden said flip it, but he did not flip it. All right, so let's start over again, guys. All right. So remember, so that was making sure that you understand it. I apologize for that. Okay, so he said flip it, but he didn't flip it. So Mr. Roden, flip it. So we have the opposite flip. So this is going to be -2/3. Sorry about that, guys. -2/3. I did change the sign. I just forgot to flip my fraction. Okay, so with that being said, change this. Get rid of this, get rid of this. Let's start that again really quick. All right, guys, so let's go ahead and redo this equation. So now we steal this equation. Now we want to steal the slope and flip it. So now it's going to be -2/3. For some reason, I want to say 3/2. Okay, now we get y equals mx plus b. We're going to replace the y with a -1 equals the x value. The m is going to be -2/3, and the x value is going to be 3, and the b is going to be over here. And we're going to get a very nice answer here. I knew this was a nice answer when I got that fraction, so that's why I was hesitating and wondering. All right, so now 3 will cancel 3 when you multiply. I like to reduce before I multiply. So this gives me -1 equals -2 plus b. See that? Now this turns out really nice. So I'll just add 2 to both sides, and -1 plus 2 is +1. So b equals 1. So our equation is equal to y equals -2/3 x plus 1. And that's going to be our answer. Again, sorry about that. But it's good practice, and this is a good, not to go off on this, but this is how math is done. We all make mistakes. we see what I noticed is I'm like, that's weird. I know that when I put answers in, I didn't put those weird fractions. And so that's okay. We all make mistakes. So go back, take your time. That's a key, is don't rush through things. And if it didn't look good or something like that, go back and do it twice and make sure you didn't do something little. Okay. All right. Number 14, lines 2x, y equals 2x and y plus 2x equals 4. Let me say it again. Y equals 2x plus 6 and y plus 2x equals 4 are parallel to each other. Well, I'm not really quite sure. So this line, I'll make one the yellow line, and I'll make one the blue line. Well, right off the bat, since the yellow line is in slope-intercept form, I know that it has a slope of 2 because it's y equals mx plus b. Now, the other equation is not in slope-intercept form, so I can't say the slope is 2 on that one. I need to put it in slope-intercept form first. So I have y plus 2x equals 4. So now I'm just going to subtract 2x from both sides to put it in slope-intercept form. Well, that gives me y equals negative 2x plus 4. Now notice the slope on this guy right here is a negative 2. This one's a positive 2. This one is a negative 2. Remember, parallel lines always have equal slopes. So this is false. It's not true. All right, last problem. Okay, so this one, here's what you had to do. You had to find, this was a 5-pointer. Most of you got at least 3 out of 5, but to get the full 5 points, here's what you needed to do. So B is the 1, 4. And C is the point 2, negative 1. E is the point negative 4, negative 3. And F is the point negative 1, 1. All right, so if we're going to do the distance formula for BC, I'm just going to put my numbers in here. BC is equal to the square root of, here's what I'm going to do. I'm going to go 2 minus 1. So I said 2 minus 1 squared plus negative 1 minus 4 squared. I'm just got to be really careful with the numbers I put in. Let's see where I got those numbers from. I put this first, I sometimes reverse it, but it doesn't matter. It won't affect your answer. I put this 2 in first for the first x value, and I subtracted this 1 for the second x value. And then I put this y value, this negative 1 in for the first y value, and I put the 4 in for the second y value. Okay? And remember, and then now I do the math here, and I get equals, well, 2 minus 1 is 1, so this is going to be 1 squared plus negative 4, negative 1 minus 4 is negative 5. So that's negative 5 squared. And if you do the math, 1 squared is 1 plus negative 5 squared is positive 25. Moving on one more step, we get BC equals the square root of 26, because 1 plus 25 is 26. So to get the full points, I needed to see that somewhere you got BC is equal to the square root of 26 to get full points. Now, let's figure out what EF is equal to. Okay, so EF is equal to the square root of, now you have to be really careful with these negatives. Negative 1, I chose this negative 1 right here, minus negative 4. I chose this negative 4 for my second x value. Doesn't matter if you did it in a little different order. Plus, I chose, let's see here, what else did I choose? I chose 1. So the second y value, I chose 1 minus negative 3. So negative 3, and then I square that answer. Okay? All right, so let's do the math here. So we get equals, well, negative 1 minus negative 4, that is negative 1 plus 4, and then we'll square that answer, plus 1 minus negative 3. 1 minus negative 3 is 1 plus 3, which is 4, and then we'll square that answer. Just got to be really careful with your rules of negatives here. So negative 1 plus 4 is 3. So this is 3 squared plus 4 squared. Okay, so 3 squared plus 4 squared. 3 squared is 9, and 4 squared is 16, right? And 9 plus 16 is the square root of 25. So EF is equal to the square root of 25. Now, you could also say, you could break that down and say, well, that's equal to 5. That's totally fine, or I didn't mark you off for that. But what you have to say is that BC is not equal to EF, and the reason why is BC was the square root of 26, and EF was the square root of 25, and those are not the same distances. So somewhere you had to say that to get the full 5 points. If you made a little error in your math in here, which is very, very typical, and it's very, not surprising. We all make those little mistakes. I had to really be careful there. Then I just took off a point or two. Okay, so I probably took off 2 points for your math, but in the end, this is what you needed to say. Okay, all right, guys, I hope this was helpful, and just take a half a point. I'll give you half a point for, I'll give you half the credit back if you want to make corrections on this. All right, see you later.